So let's pull everything we've learned about quadratics together. So here's a question. Y equals x squared plus 6x minus 1. And we want to use all of our knowledge to find all of the information we can and to sketch it. So I'm going to start with the nature of the roots. Okay? So let's start with finding what a equals, b equals, and c equals. So a equals 1, term in front of the x squared, b equals 6, and c is negative 1. So now the nature of the roots, we need to find the discriminant. So that's going to be your b squared minus your 4ac. So this will be 6 squared minus 4 times 1 times negative 1. And when I work this out, you'll see that I'm going to do 6 squared. Again, I'll type this in my brackets. Minus 4 times 1 times negative 1. And I get 40. So my discriminant is 40. Now, what this tells me is that there are two, as it's positive, there's two real distinct roots. So b squared minus 4ac is greater than 0. Therefore, two real roots. Now, from that discriminant, we can go a lot of places. So let's think next. Now that we've figured out that there are two real roots, meaning it crosses the x-axis twice, we've got to think, can I factorize? Because we want to find those roots. So can I factorize? Well, my discriminant can tell me that. If I can square root my discriminant, I can factorize it. I can't square root this to be a perfect square, so no, I cannot factorize it. So now we've got to think how I'm going to then find my roots if I cannot factorize. The other way to do it is to use the quadratic formula. So we'll take this and we'll find our roots by putting this into the quadratic formula. So we're going to have, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. If we substitute in our values now, x equals, well, our b is negative 6, so it'll be negative 6 plus or minus, we've already worked out the b squared minus 4ac. So this, we've already worked this out up here to be 40. So this is going to be the square root of 40 all over 2 times 1. Now we can split this into the two separate answers. So we'll have x equals, we have negative 6 plus or minus the square root of 40, not plus or minus, just plus, the square root of 40, all over 2. And then we have x equals negative 6 minus the square root of 40, all over 2. So here, we can type those in our calculators, and I'm going to put it to 2 decimal places. So when we put this in our calculator, I'm going to have negative 6 plus the square root of 40 all over 2. And this will be 0.16 to 2 decimal places. And then I'll press this arrow, go back, and do minus. And I'm going to get negative 6.16 to 1 decimal place, or sorry, 2 decimal places. 6.16. So I have found my two roots. I found where it crosses the x-axis. So what else can I find from this? Well, I can find, I found my x-intercepts, I can find my y-intercepts. I can also find my turning point. So let's look here, let's just follow this through. So the nature of the turning point. So meaning, is this going to be a maximum or a minimum? So this graph here is going to be a minimum. It's going to be a smiley face graph because it's a positive value out front. So my turning point is going to be a minimum. Nice little smiley face. Now, we need to find that turning point. Now to find my turning point, I need to put it in the form y equals x plus a squared plus b. Now that is your completed square form. So to find the turning point, I need to complete the square. So to complete the square on this question here, so I'll write out the equation again, plus 6x minus 1. So we need to start the square. So to do that, we look at these values here, and we're going to half it. So we have y equals x plus 3 squared, and then we still have the minus 1. Then we need to expand to figure out what we need to subtract, because we're going to be subtracting something here. So when we expand this is x squared plus 6x, which is exactly what we had at the start, and we had plus 9. There's an extra 9 there. So what we need to do is we need to subtract that 9. Right up here. So now that we've subtracted the 9, we can complete the square. So we have y equals x minus 3 squared, plus 3, sorry, x plus 3 squared, and then minus 9, or negative 9, minus 1, well, it's going to give me negative 10, or minus 10. So there, I've completed the square. Now I can say, well, what is the turning point? Well, we know when we're graphing this, that this here, we're going to shift from the center, we're going to go to the left, and we're going to go down. So my turning point, I went to the left 3, would be negative 3, and down be negative 10. There's my turning point. Next one is axis of symmetry. So actually we'll do the axis of symmetry after we sketch. Let's look at the y-intercept, because we need the y-intercept as well to sketch it. So when we look at this, we are going to substitute in x equals 0. So we have y equals 0 squared plus 6 times 0 minus 1. So y equals minus 1. So the y-intercept is when x is 0, y is minus 1. Now we have all the information that we need to sketch this. So I take a straight edge and we draw this on our graph. So we have our y and our x, and we're going to plot our points. I'm going to start with my turning point. So my turning point from my center is going to be negative 3 and negative 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way down here. So there's my turning point. Now, turning point done. I want to plot my y-intercept, which is 0, negative 1. So we're up here, so that negative 1. And now my other roots I can plot are my other points are my roots. So we have about negative 6.16. So over here, it's about negative 6.16. And then we have about 0.16. So somewhere around here, 0.16. And we have all of our information that we can sketch. So now we want to try and sketch this. So again, try and make as much of a smooth curve as you can. This one will look a little bit V-shaped because it's very tight. You could have changed the x-axis to go every 2. So it's very narrow here. Oh, I'm not sketching this very well. All right, we try and aim for a nice smooth curve, and this morning I'm clearly struggling with that. So a nice smooth curve there, as best as you can. Probably a little better if you had plain paper. And now we need to look and think about our axis of symmetry, which is the last piece of information. Well, our axis of symmetry is the line that goes directly down the center through the turning point. So we could have looked at it right here. We know that it's going through the line x equals -3. Put a dotted line up here. So we know it is going through this line. Now this is a vertical straight line. And this here is going through x equals -3. So there, we have taken all of our information that we've learned about quadratics and put it all together, and we've seen how it's all interlinked.